Began.
The wheel is one of the most important inventions in history. Its importance to humanity is equaled only by man's use and control of fire. As with fire, the action of the wheel must be controlled. Getting a wheel to roll is important. However, getting a wheel to stop rolling can be even more important. In the past, controlling the rotation of the wheel was relatively easy. That was because the power source of the vehicle also provided the majority of the braking power. But with the advent of mechanical power, control of wheel rotation became more difficult. Let's look at some of the physical forces that affect brake systems. Moving a vehicle requires energy. An engine takes the potential energy of a fossil fuel and converts it into heat energy. The engine then uses pistons and a crankshaft to convert heat into kinetic energy. Kinetic energy is the energy of motion. To move the vehicle, we use an engine to change heat energy into kinetic energy. To slow or stop the vehicle, we use brakes to change kinetic energy back into heat energy. Brakes accomplish this using friction. Friction is the resistance to motion of two surfaces in contact. Friction can be used to change kinetic energy into heat. Brake linings and the rotating brake drums or rotors use friction to convert the kinetic energy of the moving vehicle back into heat, thus slowing or stopping the rotation of the vehicle's wheels. Just as important as the friction between the brake linings and the drums or rotors is the friction between the tires and the driving surface. This friction is called traction. Good traction is essential to stop a vehicle safely and effectively. Traction can be affected by many things. Wet or icy roads will cause poor traction. So will worn tire treads. Another cause of poor stopping ability is a load that exceeds the capability of the brake system or tire traction. Early vehicles used linkage cables or rods to apply the brakes. However, as technology improved, hydraulic brakes became the standard. Hydraulics is basically utilizing fluid pressure to do work. An example of hydraulic pressure doing work can be seen in the hydraulic floor jack. Inside a hydraulic jack, the power of your arm forces a small piston down a cylinder against a quantity of hydraulic fluid. This creates hydraulic pressure, which is then sent to work against a larger piston. Because the piston is larger, the applied force is multiplied, and the car rises. The drawback is that the larger piston will not travel as far as the smaller piston. So each time you pump the handle, the vehicle will only rise a small amount. Brake hydraulic systems use the same principle to allow your foot to generate the force needed to apply the brakes. When you apply the brake pedal, the master cylinder converts pedal movement into hydraulic pressure. This hydraulic pressure is then transmitted throughout the brake system. The pressure forces the brake linings against the rotating drums or rotors. This creates the friction needed to slow or stop rotation of the wheels. Hydraulic actuation of brakes has advantages other than its ability to multiply force. One advantage is that pressurized fluid can be sent to all parts of a vehicle through small tubes and hoses. Another advantage is that different amounts of pressure can be sent to each wheel. This ensures that the brake force applied is correct for the vehicle's weight transfer during braking. Now let's answer some review questions to help you assess your understanding of the information you've learned. After a question is asked, pause the tape. Once you've answered the question, restart the tape and compare your answer with the correct one. The first review question is, brake systems convert kinetic energy into what type of energy? The correct answer is that brake systems convert kinetic energy into heat energy. If you answered differently, please review part 1 of this video. Let's try another question. What are two advantages of hydraulic brake systems? Some of the advantages of hydraulic brake systems are the ability to multiply force, the ability to carry pressurized fluid to all parts of the vehicle through small tubes and hoses, and the ability to send different amounts of pressure to each wheel. If you listed any two of these, you're right. If not, review Part 1 of this training video. Before beginning Part 2 of